Another definition that you guys have to know is independent events. Two events A and B are independent if the occurrence of one does not affect the probability of the occurrence of the other. If A and B are not independent, they're said to be dependent. And an asterisk note, do not confuse mutually exclusive and independent events. So let's take a look at some examples of independent and dependent events. So it says event A, today's forecast predicts a 95% chance of rain. Event B, you bring an umbrella with you to school. So question, if event A occurred, the forecast says there is 95% chance of rain. Does that change your probability of bringing an umbrella? And if the answer is yes, that means that the events are dependent. They're not independent. So the probability of event B is changed when event A happens. Okay, so that's the definition of independent events. They're not mutually exclusive. This is a completely different type of relationship, independence. All right, so another example, event A, finding that your calculator is working, and event B, finding that your cell phone is working. Are those dependent or independent? I'm gonna let you think for a second. Okay, so the answer is events are not dependent, they're independent. So the probability that your calculator working or not working does not affect the your cell phone in any way. So these events are independent. Now the next set of events, having the day's lowest temperature of 60 degrees Fahrenheit, that's event A. Event B, snowing on that same day. So if you find that the lowest temperature of the day is 60, does that affect the chance of snowing on that same day? Again, I will give you a second to think about it. And I would say the answer is yes, they are dependent. They're not independent events. Whether we have snow or not largely depends on the temperature of the day. So if the temperature is high, it's less likely to snow. So the events are not independent, they are dependent events. So now let's talk about multiplication rule. So the multiplication rule says that the probability of A and B equals the probability of A given B multiplied by probability of B. Now, when events A and B are independent, then basically probability of A given B just gonna equal to the probability of A. All right, so again, when the events are independent, remember, the fact that event B happened does not change the probability of event A. So it's just going to be, so probability of event A given B is the same as just the probability of event A. So your multiplication rule simplifies into probability of A times the probability of B. So, and in the next question, in the next example, we're going to use multiplication rule to check if events Y2 and R3 are independent. And the way we're going to do it is we're going to use these multiplication rules. First, we're going to try this calculate the probability using this format, and then we're going to do it using this format and see if we come up with the same result. If we do, then the events are independent, because now we will prove that P of A given B is the same of just P of A. Okay, so let's do this. So right here, this is our multiplication rule for dependent events. Okay, so let's figure it out. The probability of Y given Y2 given R3 is the probability of Y2 and R3, which is 0.15, divided by the probability of R3, which is 0.25. And then we're going to multiply that by R3. So 0.25. And that's going to be 0.15. Now let's try the multiplication rule for independent events. Which is going to give me P of Y, probability of Y2 multiply the probability by R3. So the probability of Y2 is 0.42. I'm going to multiply by probability of R3, which is 0.25. Let's see what we get. And I got the probability of 0.105, which is not the same as 0 as I found using the previous method. And that just tells me that the events are dependent. So that's the conclusion that we come up with. Since P of Y2 given R3 multiplied by P of R3 does not equal to P of Y2 just multiplied by P of R3, then we conclude that Y2 and R3 are dependent events.